Hello?
Hi.
Yeah, so I think I can start the presentation. Okay.
Go ahead.
I have to switch my camera on as well. Okay. Do you see my screen, my presentation screen?
Yes.
And you see it now in presentation mode?
No.
Okay. I don't know. And like this, it's better. You see it like this?
It's okay.
So okay, I do it in this way. Otherwise, so I'm working for the company ClearSea, which has 4 offices in France, and we are about 130 employees. We have 4 agencies. The headquarters are in Aix-en-Provence, and we have an office in Lyon, 1 in Paris, and the last office, the smallest office, is in Strasbourg, where I am. And we have let's say two businesses. We have safety solutions, where we make safety critical systems or software up to SIL4 for railways. And we use formal methods for studies or for code generation for CBTC projects, for example. And this is the historical activity of ClearSea, safety solutions. And then the second activity is ERTMS ETCS solutions through the acquisition of ERSA in 2018. And the activities of ERSA are DMI software, which can be installed in many hardware, and simulation tools for testing and training. So there are 3 families of simulation tools: tools for testing onboard system, trackside systems, or a combination of onboard and trackside; systems for training of engineers, training for trained drivers, either for a single driver or for multiple drivers in parallel. And then a last part is for studies, making proof of concepts, studying operational situations, studying braking curves. So a lot of things about studies. And what is really approach which we are following in ClearSea or ERSA is that our simulation tools are always fully compliant with the norms. So we are not making simplifications. We do it exactly like in the norms. And this allows us not only to show nominal situations, but also many, many degraded situations, which are the most difficult to simulate. Our simulation is very accurate, so we go up to the level of bits in balise telegrams, just to give you this example. And we have decomposition, functional decomposition between modules with interfaces which are always compliant with the norms. And for these reasons, because of this accuracy of the simulation, we can use directly project information, project data, to be imported in the tools, and it works directly. We can instruct trained drivers, but not only, we can also instruct signaling engineers with these tools. And we can replace simulated components by industrial components to make it possible to convert the simulation, pure simulation, into test tools, into test bench. From the V model, which I received, I tried to see where we could provide tools. And let's say at the beginning of the project, in the study phases, can be used for simulation of operational situations, trying parameters and so on. When we go further in the V cycle, when we go to, we can use it for testing. And in the commercial part, it can be used for training. Training is really at the end of the cycle, usually. So the simulation tools, we have 2 categories. We have for studies and training. And if it's for a single train, it's an operational simulator. It's for multiple trains, it's a traffic simulator. And for testing, we can test the onboard part, we can test the trackside part, and we can test them combined in an IOP test bench. So a few words about each simulator. So the operational simulator is the smallest one. It runs on a laptop. It's very small, but very powerful. It has the full function of the onboard system inside the laptop. So we have it for baseline 2, we have it for baseline 3. And we have, as I have explained previously, we have interfaces, and the interfaces are really like in the norms. And it can be used for training, as I explained, not but only, also a lot of other things, research and so on. I will make a demo of this tool in the second part. For this small simulator, we have also options. We have certain functions which are good for training, like replay function, context management, where, for example, you store a situation and you restart from this situation. We can implement STMs. As we did, you can see we have made the Dutch STM. We can also connect it to an external 3D system. Then the second product in simulation, pure simulation, is a traffic simulator, where we have a complete model of a railway. So we simulate all trackside components like interlocking, RBC, automatic route setting system. We simulate the track component, the signaling objects, and of course the ETCS equipped trains. And this works so many, you can include many trains into it. We can also include the operational simulator into it with or without 3D. And you can see an example of training. This was in the Netherlands for STC. There were 7 operational simulators running in parallel on the same track. And there was somebody, an instructor, creating scenarios, but also, let's say, managing the simulation by giving movement authorities through the RBC, or injecting errors and so on. Now the part related to testing. So we have tools to test the onboard system. So the onboard system can be put here, and we create the environment around it. So being at the interfaces, like really defined in the subset. And we have 2 types of, we can use either subset 94, or we have subset 111.2. Here are some pictures. We make it realistic. And here on the left side, you see testing in the SBB premises. And the others are, let's say, component of the test. Another type of test is for trackside, testing the RBC. And usually we are not testing only RBC, but it's combined with its interlocking. And the interface with the RBC is via ISDN and Euroradio. And on the interlocking side, it's a proprietary protocol usually. And we have made for ProRail RBC test bench for the Amsterdam-Utrecht line a few years ago. So now I will make you a demonstration of the smallest operational simulator. So, but just about the principle, you have a tool to prepare scenario offline, and in this tool you have to define what is going to happen to the train when the train is moving, and according to time. And you define the balise telegrams, you define radio messages, you define events like signal aspects and so on. And this is all stored in a scenario which you then call, and then you execute in real time. You have a DMI, you have a view of the track, and you can optionally see the braking curves if you want to study this part. So now I'm going to switch to the demo. Do you see a screen with a blue background?
Yes, we do.
Okay, so now I switch to the tool. So the tool is accessible. It is on our server, so you can remotely access it. And I first starting the scenario controller. So this is now the screen. I select a scenario, which I have created previously with the scenario editor. So I take this one. Now you should see a nice picture of the simulator. So you have a 3D view. You see the track here, and you see the train at the beginning. And what is moving is the track, not the train. So it's simpler to do in simulation. And you see an object like a marker board here, and we see that we are in a station. Here, what is black at the moment is the DMI. For the moment, it is switched off. And on the right side, you have a small desk for the driver. So I will manipulate the desk, and you can imagine there is an EVC inside, an EVC simulator, which is a state machine with many interfaces, and then we are now touching the interfaces to make it let's say make a live. So I switch on the TCS part. I enter I open the cabin, and the cabin is opened. The DMI pops up. So you see how it is. And the first thing which has to be done according to the norm is to enter the driver ID. So I just take a default value, which is 0. This is a scenario with level 2. This means that a connection is established with the RBC. And you can see that the connection is established here. And we are in level 2. We see the train speed, which is 0 at the moment, and we are in standby mode according to the norm. We can make a train movement or a shunting movement, as you can see here. But to make a train movement, we have to enter train data, which I will do here by clicking this button. So I have some default value which are here. I can simply accept them. They are passed from the DMI to the EVC, controlled by the EVC, sent back to the DMI, and the driver has a last word to confirm if he's okay with this. And then if he's okay, he pushes yes. If not, he has to restart the procedure. So let's do yes. Then the next thing is to enter the train running number. So again, I have 0, but I push this default value. What is happening also is that there was a communication between the EVC and the RBC, and I can see the communication. If I look at on the top of the train, there are some bubbles. So I see when it's an incoming radio message or an outgoing message, I can see this on the train. So I push the start button here. This means that I would like to get a movement authority. And this means that EVC will send a request to the RBC. And then it is expecting a reply. So I will push start, and you will see that there is a message going out. And there is a reply. So I received, I know it's authorization to move in on-site mode. I can also, if I am just starting to understand the system, I can add a window where I can see, it's a kind of debugging window, where I can see all the messages exchanged between the EVC and all other components. So let's just remove the window. I have to click on this icon. And now the current mode is OS. And I'm able to drive my train. I go now to the left, to the right side, where I have the manipulator. So you can see that the train is moving. I can give some more acceleration. Here you see 2 points, 2 yellow points. These are 2 balises. I want to show you what happens. So there is inside the simulator a BTM which reads the balise message and reacts accordingly. We are at the moment in on-site mode. This means that we could be in a section which could be occupied by another train. So we received a message TAF confirming track ahead free. We will confirm because there is no train between where we are and the next marker board. And here we switch to full supervision now. We see it because we have this symbol here. And we see also a maximum permitted speed, and we see also the planning area here. And we can also optionally, if you push a certain button, you can see the braking curves. And you can see that the train is not it's not a point, but it's an interval, confidence interval. And we take this into account, of course, and we have a model for the odometry. We see also we are in sailing speed monitoring. We see that we are approaching from the target here. I can, for example, make a pause if I pause of the simulation, if I would like to explain something. And for example, the values, the braking curve is quite complex, but you see, for example, you have the indication limit, permitted limit, warning limit, and all the values you can see them in the simulation by clicking here. This is why, for example, this kind of tools can be used for engineers because it goes into very details. Okay, so this is this simulator, and you have access to all the packets, all the telegrams, so you can simulate any situation from the norm, included all degraded situations. So it's a tool which has all the functions. I think I'm going to stop here because it could show a lot of scenarios, but to convince you that we have all the functions. Maybe I can just show you the scenario editor a little bit. Here, for example, it's a level 1 example. I see the train in yellow and I see groups of balises. And I, for example, can show you the content of a balise. I click here. I see that there are 2 balises. I push here, edit. And you can see this is the header of the balise, exactly like in subset 26. Then you can go to see the packets. Packet 12, packet 21, 27, 80. And there was an example with LS mode, limited supervision. And here you see the possible packets. You see all the packets which are possible. I'm interested in one. For example, this one. I push it here and I click here, and then it comes here. I can enter the data. In other simulators, here you do it manually, but in other simulators we can import project data, so it can be very powerful. Otherwise, if you do it by hand, telegram by telegram, it could be painful. Okay, so I think this is the end of it because there is not much time. So if you have questions, I'm quite happy to answer them. I don't know if somebody's there. So I think maybe I was a bit quick, but
You still have 5 minutes left.
okay, but so for questions, if there are questions.
No questions. I think that looks very good. Yeah.
It's for example, the one which I've shown you is very small, but it's I can give you an example. It's this small simulator. It can be embedded in bigger simulators, and for example, the Transurb has used it for NMBS. So it is used for as a specific module embedded inside the Transeurope simulation. They did the trackside part, so sending the balise messages, and we made the complete onboard part, which is capable to understand all messages from the norm and also to control the DMI.
Patrick, do you also use it for troubleshooting, for engineering problems, or when you're later in the right side of the V-curve, you have specific problems? Can you use the simulation as well for debugging problems?
Well, you can use it for many purposes. For example, I can give you some examples. It was used in the UK to help them to define a standard for the way to show information about the national system when switching from the international context to the British context. For example, going from miles per hour to kilometer per hour, this should be done, and so on, and which information should be shown when, and which text messages and which icons. They used this simulator for this purpose.
Okay.
But there are many possibilities, because it's a kind of you can install, for example, the ETCS simulation inside the train. For example, you can connect it to.
Yes.
You have for example, a demonstrator of the onboard functions. You can install it in a train. You can understand. There's something for SBB last year.
Yes, I'm Martin from ProRail. We use it also to test out scenarios for engineering. So we have a version with baseline 3. And we used it also in testing, which was interesting for the Amsterdam-Utrecht. Then the simulator was used to test the RBC and then actually the onboard software, the simulator, was not used to validate, but to generate the messages from the RBC. So the onboard was driving over a simulated line of Amsterdam-Utrecht, and all the messages that the RBC sent were captured, and they were checked against the engineering information. So there, this simulator was used to have the RBC generate MAs, and the MAs were then used in the validation. So we use this concept in different ways. We use it to test engineering, and we use it also to really validate the RBC. But it was a nice tool, very flexible.
Thank you.
Yeah.
It is also used, for example, for replication of lines. When you have for SBB, it's used a lot, and Thales, when they have, let's say, implemented a line, but they want to have in lab the same. So they have their own products, RBC, interlocking, CTC, but coupled with our simulation environment, with multiple trains and truck simulation.
Yes.
Then they can completely in the lab reproduce a line for testing purposes.
Yes. So we also have, in the test lab, we can use this computer, or we can use a real onboard. And Patrick, is it now complying also to the subset 111, so that you can use it? Yes. So what are you in our test environment? We have done real RBCs, and we can use it with this simulator, but we can also use it with real onboards. But sometimes you want to do additional trains, and then you can add this. Actually, you can use it as an onboard, this simulator. Yeah.
Yes.
Yeah. And I use it also sometimes to test out a scenario, which I think should work, but I want to make sure if it works. And then it's easier to do it in this environment than to go to the real onboards, because that programming is sometimes a bit more difficult than what I can do with your scenario evaluator. That works faster for me, so that we use that to test out new engineering ideas.
Okay.
Yeah.
I think they will normally at 40 they will stop.